Okay, hi everyone. We are going to do a lab, and since you aren't here, I'm going to actually collect the data for the lab for you so that you can complete the work with it, the analysis, which is the important part for this. This is a mole and mass conversion lab, so it's practicing those molar conversions that we went over in the notes. Okay, so you have a lab sheet on your resources and on the website that you need to open so you can fill in as we go. I am going to do the first one in each section because we have a solid samples and liquid samples. I'm going to do the first one in each section slowly and talk you through it, and then I'm going to finish the rest of them quickly and just give you the data at the end. At the very end of this video, I will post all of the data for each of the samples in case you missed one. Obviously, it's a video, so you can go back and watch it again if you need to. All right, so let's get started. We're going to start with the first solid on the list, which is sodium chloride. All of our materials are here out in front of me, and I have note cards so I can record the data for you as we go. So the first thing we're going to do is find the mass of a teaspoon of sodium chloride. As you know, we do not put chemicals straight on the pan of a balance, so we use a container to hold the chemicals. We're going to use a little cup in this case. And we need to find the mass of our container because we don't want to use the mass of the container in our calculations. We just want the mass of the chemical. So, to find the mass, we will use our centigram. Remember, centigrams are accurate to the hundredths place, which is more accurate than a triple beam balance, which is why we like to use them in chemistry. Okay, so that looks pretty good. The mass of our cup is going to be 1 point, and it looks like it's 1.78, and we're going to estimate that next digit to be a 2, 1.782. Okay, so now we're going to add our teaspoon of sodium chloride. It's just a scoop. We want to try to get the same amount of each substance. So I'll try to figure out that I add the same amount in my spoon each time. All right, so now let's put this back to 0 and start over. We'll see if 10 is too much. Yes. And we'll go 7, 8, 9 is too much. So go back to 8. Hit it a little too hard. Okay, that looks pretty good. So the mass of the container and the sodium chloride is going to be 8 point, and it looks like it's almost right at 3, so 8.301. It's not exactly right on the line. And so now you are going to have to calculate just the mass of the sodium to complete the analysis of the lab. We do not want to take into account the mass of the cup. So this is where we do massing by difference. If you will recall, we've done this in multiple labs this year where you subtract. Okay? All right, so now I'm going to stop here and I'm going to do the other 3 solids quickly and show you the data so that you don't have to sit and listen to me talk the entire time. We're moving on to the liquids. There are 5 liquids. Just to remind you, for the solids, we only did 4. We did not have dextrose, so we're skipping that one. And maltose is the same as sucrose, which I had in the lab, so we used that substance instead of maltose. Just a heads up. Now we're going to move to the liquids, and I'm going to find the mass of the container. For liquids, we are using a graduated cylinder because we're going to measure 10 mils of each liquid, and then we'll find the mass first, then add the liquid, the 10 mils, and find it together. I'll record it on the card for you like I did last time, and so that you'll have the data. All right, here we go. All right, so this graduated cylinder is going to be glass, so it's probably pretty heavy. It's moving, so I'm going to try to stop it a little so it won't. Looks like this is going to need to be 6. Maybe I didn't have it in a groove, a notch. Okay, that looks good. So the graduated cylinder that we're using is 26.225. And I am going to reuse the same graduated cylinder for each of these because I can rinse the liquids out pretty well. So this will be our mass of this graduated cylinder for all of them except glycerol, because glycerol I've already prepared. All right, so now let's add water. I'm going to get the water from the sink. So I'm going to move to the sink, fill it up with 10 mils. Oh, that looks like I have a little bit too much. Fun part of getting it exactly right. Drip, drip, drip. Okay. All right. So now I have 10 mils of water. So we'll add that to our balance. Oops. So let's get this there. Trying to get as close as I can. All right, so that looks good. It looks like it is 36 grams, so 36.160 grams. And as we did for the solid, you're going to have to find the mass of just the water using massing by difference. Okay, so that's the water. And now I'm going to do the rest of them quickly, just give you the data so you don't have to listen to me talk. concludes the data collection part of this lab. You are now going to complete the data analysis for each substance. You will do the questions. So I'm going to just read them real quick, make sure they're clear. You're going to calculate the number of moles using our molar mass that we learned. You are going to then calculate the number of atoms, molecules, or formula units. So the reason that all three of those units are there is because you have to determine which unit is the most appropriate for the substance, for each substance. So you have to identify, is atoms the representative particle, is the molecules the representative particle, or are formula units the representative particles? And then complete the other questions. Make sure you show your work. Do not just give me an answer, because remember, what this unit is all about is the conversion, which is the mathematical setup and problem solving that you're doing. All right, as always, if you have any questions, please email me, message me, and we will work it out. Good luck.